Torresol Energy is the company that was created following the merger of Masdar and schneider. Masdar is owned by the Abu Dhabi government and schneider is an old Spanish engineering company. Torresol Energy was created as a result of this joint venture. Our plant in particular has an additional point, which is the extremely high level of manageability. Ours is a very simple process, based on capturing the sun's energy, concentrating it in the tower, and storing it in one of the tanks, a hot salt tank. From that point on, my plant is no longer a solar power plant, but behaves much more as though it were a thermal power plant. From this moment onwards, when I decide, we'll draw energy from this kind of lung or tank of energy to turn it into steam, and use the steam to produce electricity. But that will be our decision. We will decide when and at what time we'll be supplying the energy that we've captured during the day.
The gemasolar project plant is a tower technology plant, a thermosolar plant with molten salts and a central receiver, which, as you can see, is made up of a series of heliostats, 2,650 in all, whose job it is to concentrate the solar energy that they receive in the molten salt solar receiver and heat the salts that pass through it. These are then stored in a hot tank at 565 degrees and then used in the steam generation system to produce the steam that will drive a turbine and generate electricity. This power plant generates about the same amount of energy used by 25,000 homes in a year. It is a thermosolar plant that offers the new feature of being able to work and provide non-stop operation for 24 hours, with very high annual operational times, close on 6,500. Given the technology it implements, it also lets us disconnect the, well, we'll call it solar energy from the production of electricity. Above all else, we have always placed great value on a detailed technical response. Our type of work means that we have to have partners who can provide us with technical support in developments and evolutions to make these type of projects possible. In this case, with Schneider, we had a certain tradition in various past projects with other technologies and for other applications. This project has represented a new impetus in our working with this type of technology. In the initial phase of the project, we had to face technological challenges, such as the communications network of a solar field with 2,650 heliostats. We had to tackle the technical solution to a huge harmonic distortion in a solar field that had 5,600 variable speed drives installed in it. We also had to equip the control system with a tool that was capable of implementing different subsystem solutions of different controls. This meant that right from the start, we had to look for solutions with a high degree of flexibility and possibilities for expansion. Plant structure makes it possible for us to have a plant with complete integration capacity of all the control systems. It's an open tool, a hybrid system that is necessary for us in the sense that we have a high volume of information, which has allowed us to register points on both a supervision network and on a control network. It has allowed us to connect to any of the minor plant control systems, such as the package systems, or even a turbine control system, or the calibrated thermography systems. In other words, with any hardware or even software system, with the capacity to develop integrated software in the control tool through a specific driver later. This is only possible with a tool that can obviously only be open. At the project level, we have different needs in different elements. We have a solar field that has mid-range PLCs that have to be managed by the plant's principal control platform tool. This requires a highly specific communications network that demands not only a great deal of flexibility, but, above all, a great deal of sturdiness, reliability, and speed. It has to be able to allow a common command to all the components in a very short time in light of any specific action. We also need the solar field to allow simultaneous movement with 5,600 variable speed drives. In this case, we need active filters that are working in real time, offsetting the solar field's low voltage network because otherwise their simultaneous movement would not be possible. Evidently, as it is a generation plant, we need the right installations and electrical material that is cutting edge from the point of view that it can communicate with the control system. It can be managed from the control system with a small number of personnel on the ground, and it can carry out almost any action from the control platform. It is very valuable to us that the solution implemented by our control system is one that allows not only hardware, but service from the point of view of control software programming integration and an on-site startup assistance service. This cycle that ends our initial basic engineering work is the key to this type of technology and these types of plants working.